The story of engineering doesn't start with blueprints or cranes. It starts in the wild, in the quiet places where nature has been perfecting designs for millions of years. When we look closely, every corner of the natural world is filled with ingenious solutions to problems we thought only humans could solve. You've seen how bees build and birds weave. But what about the ones that don't build at all? What about the engineers whose genius lies not in the structures they create, but in the way they move, adapt, and interact with their world? Consider the snake. No arms, no legs, no tools, just a body built for movement. You might think its limbless form would be a disadvantage, but the snake has turned it into a superpower. With nothing but a series of coordinated muscle contractions and a masterful use of friction, it glides across the ground, climbs trees, even swims through water. This is serpentine locomotion in action, a dance of force vectors and traction, allowing the snake to slip through places no other animal can reach. Now, imagine a disaster zone. Collapsed buildings, twisted metal, spaces too tight for any human or machine. Enter the snake-inspired robot. Engineers have studied the elegant movement of snakes, breaking down every undulation, every twist and turn, to design robots that can crawl through debris, search for survivors, and deliver supplies. Where wheels fail and legs can't go, serpentine robots succeed. It's not about brute force, it's about adaptability, about moving with the environment instead of against it. And then there's the elephant, majestic, powerful, yet incredibly delicate when it needs to be. Its trunk is one of evolution's most remarkable inventions, over 40,000 muscles working in perfect harmony. With it, the elephant can uproot a tree or pick up a single blade of grass. It pours water, breaks branches, reaches food high in the canopy or deep underground. The trunk is both strong and gentle, precise and adaptable. Engineers have long admired this natural marvel, and now they're bringing its secrets to life in the world of soft robotics. Traditional robots are rigid, built from steel and plastic. But soft robots, inspired by the elephant's trunk, are made from flexible materials that can grip fragile fruit, handle delicate medical instruments, and even interact safely with humans. It's a revolution in design, machines that don't just mimic the strength of nature, but its subtlety and sensitivity too. Snakes and elephants may not build nests, hives, or towers, but their influence on engineering is profound. They remind us that sometimes the key to innovation isn't creating new structures, but reimagining how we move and interact with the world around us. But let's not forget the classic builders of the animal kingdom, the ones whose structures have inspired everything from skyscrapers to satellites. Bees, for example, are the masters of optimization. Their honeycombs, built with perfect hexagons, use the least amount of wax to store the most honey. It's a lesson in efficiency that has found its way into everything from architecture to aerospace engineering. Birds, too, have much to teach. Their bones are lightweight, yet incredibly strong, thanks to a careful balance of structure and material. Engineers have borrowed these principles to design aircraft that are both sturdy and light, able to soar higher and farther than ever before. And then there are the termites, tiny insects that build some of the world's most sophisticated structures. Their mounds are masterpieces of climate control, maintaining stable temperatures and humidity levels, no matter what's happening outside. By studying termite mounds, architects have developed buildings that stay cool without air conditioning, saving energy and reducing our impact on the planet. Weavers, meanwhile, construct intricate fiber structures, creating nests that are both beautiful and resilient. Their weaving techniques have inspired new materials and construction methods, pushing the boundaries of what's possible in design. But what about the spider? Often overlooked, the spider is perhaps nature's most talented fiber engineer. Its silk is stronger than steel by weight, yet flexible and incredibly light. Spiders use this remarkable material to spin webs that can catch prey, protect eggs, and even serve as parachutes for young spiders drifting on the wind. Scientists are racing to replicate spider silk in the lab, hoping to create everything from bulletproof vests to biodegradable medical sutures. The spider, with its silent artistry, is teaching us how to build better, stronger, and more sustainable materials. Let's pause for a moment and reflect on what this all means. In the world of engineering, there's often a temptation to build bigger, to use more materials, to add complexity. But nature shows us another path. Sometimes, the most elegant solutions are the simplest. Sometimes, the greatest innovation comes not from thinking outside the box, but from observing what's already around us. That brings us to an unexpected twist, a moment to recognize the unsung heroes of bio-inspired engineering. We've marveled at bees and birds, termites and weavers, but what about those whose genius lies in movement and adaptability, the ones you didn't expect?
Snakes, no tools, no limbs. Yet engineers are copying their every move. Their muscular motion inspires search and rescue robots that move where wheels can't, like collapsed buildings or deep inside machinery. It's called serpentine locomotion. No legs, just force vectors and friction control.
And elephants, they don't build nests or hives, but their trunks? One of the most versatile biotools on Earth. Over 40,000 muscles, a miracle of flexible robotics. Engineers study it to design grippers for fragile objects, from fruit to human organs. It's soft robotics, drawn straight from the savannah. These animals may not build structures, but they've built the future of robotics, movement, and adaptability. They remind us that in nature, sometimes the most brilliant engineers don't even carry a toolbox. So, where does that leave us? What lessons can we take from these natural innovators? It's clear that bio-inspiration isn't just about copying shapes or structures. It's about understanding the underlying principles that make nature so efficient, resilient, and adaptable. It's about function over form, about learning to solve problems the way nature does, through trial and error, through constant adaptation, through a deep connection with the environment. Let's take a closer look at the engineering concepts these animals have inspired. Serpentine locomotion teaches us about movement via muscular waves and traction control, how to navigate complex environments with minimal resources. Soft robotics shows us the power of flexibility and adaptability, of machines that can grip and move like living creatures. And the contrast between bio-inspired design and traditional engineering challenges us to rethink our approach. Sometimes the best solutions aren't the most obvious ones. As we wrap up this journey, let's celebrate the full cast of nature's masterclass in engineering. Picture a quick montage: bees, optimization; birds, lightweight strength; termites, climate control; snakes, mobility engineering; elephants, soft robotics; weavers, fiber structures; and, of course, spiders, material mastery. They don't wear hard hats, they don't draw blueprints, but they've shaped skyscrapers, satellites, and even robots. Not by design, but by instinct. Maybe the future of engineering isn't about thinking bigger, but observing deeper. Nature's engineers have been at work for millions of years, perfecting their craft through countless generations. Each solution, each adaptation, is a testament to the power of observation, experimentation, and resilience. As we face the challenges of the modern world, climate change, resource scarcity, the need for sustainable technologies, we have more to learn from these natural innovators than ever before. When we study the bee, we learn the value of efficiency, how to do more with less, to build strong and stable structures using the minimum amount of material. From birds, we discover the secrets of lightweight strength, how to soar to new heights without being weighed down. Termites show us how to create comfortable, energy-efficient spaces by working with, not against, the environment. The snake teaches us that movement is an engineering challenge all its own, that with the right design, you can go places no one else can reach. The elephant's trunk reminds us that sometimes the best tools are the most flexible, able to handle anything from the heaviest load to the most delicate touch. Weavers inspire us to think creatively about materials, to weave together strength and beauty in every project. And the spider? The spider dares us to push the limits of what's possible, to create materials that are stronger, lighter, and more sustainable than anything we've built before. Together, these animals form a living encyclopedia of engineering solutions, one that's always growing, always adapting, always finding new ways to solve old problems. If we're willing to watch, to listen, to learn, there's no limit to what we can achieve. So, the next time you see a bee buzzing in the garden, a bird soaring overhead, a snake slithering through the grass, or a spider spinning its web, remember, you're looking at a master engineer at work. Their lessons are written in the world around us, waiting to be discovered. The future of engineering is wild. It's untamed, it's unexpected, and it's all around us. All we have to do is pay attention. Bees optimization. Birds, lightweight strength. Termites, climate control. Snakes, mobility engineering. Elephants, soft robotics. Weavers, fiber structures. Spiders, material mastery. And all of them, nature's masterclass. Maybe the most important lesson isn't just how to build, but how to observe. To look deeper, to see the hidden connections, to find inspiration in the unlikeliest of places. Because sometimes, the greatest innovations come not from what we create, but from what we discover. And in the greatest laboratory of all, nature itself, the possibilities are endless.